Achha, so it was specifically about these carbon atoms. Okay, which ones are lying in the same plane? That's what the question is. And I told you that even if, I mean, these were all the shapes of the molecules, and I told you that even some of the shapes are planar. That means they're completely flat, lying in just one plane, linear, bent shape. Trigonal planar, that's lying flat. But I told you that shapes that are trigonal bipyramidal or tetrahedral or this octahedral shape, even there, if you talk about some of the atoms, they would be lying in the same plane. Okay, for example, if you talk about these atoms, they are linear, they're completely lying straight in one line. So the question is, in which molecule do all the carbon atoms lie in the same plane? So the first one is 2,3-dimethyl but 2-ene. Okay, right now you haven't studied organics, so 2,3-dimethyl but 2-ene is, you start off with but, that's 4 carbon atoms. So that's 1, 2, 3, and that's your fourth carbon atom. So 2-ene means there's a double bond between the second and the third carbon atom. That's where you've got a double bond there. And 2,3-dimethyl means that there's a methyl. So there's a methyl on the second one, and there's a methyl on the third one. Now, I'm not going to draw all the hydrogen atoms because the question is specifically about carbon atoms. So I'm just going to leave it there. I don't care what this carbon is bonded to. I'll just focus on these carbon atoms. I'm going to ignore all the other atoms. So the question is, what would be the shape? Is it planar or not? Do they lie in the same plane or do they not lie in the same plane? That's the question. So around this carbon atom, you've got 3 pairs of bonds. You've got a bond over here, you've got a bond over here, and you've got a bond that's over here. So that's 3 pairs of bonds. So when we talk about shapes, when you have 3 pairs of bonds, the shape is going to be fan shaped. It's going to be planar. It's going to be trigonal planar, just like a fan. So it's going to look something like this. So the first one is, जो सबसे पहला है, that is कि if I draw the exact shape of this particular carbon atom, it would look like a fan with a double bond on one side, and just like a fan, all the bonds are going to be like a fan. So there would be a carbon atom, another carbon atom, and another carbon atom over here. और फिर उसके आगे भी that's going to be planar. It's going to be one carbon atom and the other carbon atom. So it's basically planar. All the angles are 120 degrees. It's like this one is like 2 fans connected together. The first one is planar because there are 3 pairs of bonds. Okay, remember, double bond is one thing. Okay, so there are 3 pairs. One pair over here, a pair of bonds over here, a pair of bond over here, a pair of electrons over here. So there are 3 pairs of electrons, bonded pairs, and it's going to be fan shaped. So this entire molecule, at least the carbon atoms are planar. Beyond that, it's not planar. Like, I did not draw the hydrogen atoms, but the question wasn't about hydrogen atoms. It was about carbon atoms. So beyond that, carbon would be making 4 bonds. So it would be tetrahedral, which means tetrahedral shape is like this. Okay, there would be. So beyond that, it's not going to be planar. I mean, this H is coming out of the page. It's coming towards you. That dotted is going into the page. So beyond the carbon atoms, nothing is planar. The H atoms are definitely not planar. They are tetrahedral because there are 4 of them. So if I limit myself to the carbon atoms, then it is planar. I mean, all the carbon atoms lie in the same plane. TK, is this clear? So there's this clear. Oswa, Mahad, is this clear?
Yes.
So the next one. TK, so you have to be careful about this. I mean, the entire molecule was not planar. I mean, bonds were coming out of the page, jumping out of the screen and going into the screen. But at least the carbon atoms were planar. So the question was very limited. It was specific to carbon atoms. Let's look at propane. So let's focus on propane. Propane is, what is propane? It's 3 carbon atoms. It's an alkane. So propane is 3 carbon atoms, and the rest are hydrogens. But remember, we're not concerned with the hydrogens. I don't care about the hydrogens because the question is all about the carbon atoms. तो यहाँ पे ये सारे H हो गए, ठीक है, वो हमने बीच में फिट कर दिए, ठीक है. So that's but remember, we don't care about the red ones, ठीक है. The whole question is about it's about the carbon atoms. Let's focus on this middle one. 4 bonds is tetrahedral. Whenever something has 4 bonds, so it's this one. 4 bonds is tetrahedral. It's like a pyramid at the bottom and 1 bond coming on top of it. So it is tetrahedral. So I'm going to draw that. I'm going to draw this carbon atom, which is tetrahedral. So uska matlab hai ki it is 1 bond on top, 1 on the right side, sorry, left side. Then you have a bond that is, and then you have this dotted bond that is going into the page. So this is the central carbon, central atom. So wo kis sath bonded? It's bonded to 2 carbon atoms. So there's 1 carbon atom over here, and there's another carbon atom over here. So I'll just limit this to this part. So it's 3 carbon atoms. The middle one is tetrahedral. Uske baad bhi tetrahedral hai. I mean, the other carbon atoms are also making 4 bonds. So these are also tetrahedral. So that means इनके साथ भी ना it's one wedge-shaped bond that's coming out of the page. ठीक है, and there is this अच्छा ये सारा. So H इसके बाद भी it's tetrahedral, so but we don't care after this, ठीक है. So it's H, H, and H, and these two are also H's. But the whole question is revolving around these carbon atoms. I'm going to so the whole question is revolving around these carbon atoms. So imagine the whole entire rest of the molecule disappears. Okay, ignore all of that. The other ones are not planar. They're coming, the bonds are jumping out of the page, they're going into the page. So they are definitely not planar. But the entire question is about कि carbon के साथ क्या चल रहा है, is the carbon atoms, are they planar or not? So I told you कि when you have, so you can think, wipe the rest of them out. Okay, just ignore them completely. So when you have 3 bonds, just 3 of them, and it's a bent shape. Okay, just focus on this, the carbon atom. When it's bent, a bent shape can be planar. Here's your example. This is a bent. I mean, the red, yellow, and red, they are bent. They can lie flat on a plane. So this shape is planar. So that means these carbon atoms are basically lying in the same plane. उसके बाद बाकी कुछ भी plane के अंदर नहीं है. I mean, the H atoms, tetrahedral, it's like the pyramid side that's jumping out of the page, coming towards you, the dotted one that's going into the page. Again, you have this small pyramid, 1 bond coming towards you, 1 going into the page. So the rest is definitely not planar, but the carbon atoms are planar. ये भी clear है? Is this clear? Is this clear? ठीक है. So the last one is the trickiest. Remember, this whole question was tricky because it wasn't talking about the shape of the entire molecule, just the shape of very specific atoms. The last one is the difficult one. It's cyclohexane. So you have to understand this a bit. Cyclohexane is this molecule. Okay, cyclohexane is, it's 6 carbon atoms in a cyclic structure. So 6 of them in a cyclic arrangement. And every carbon atom makes 4 bonds. Okay, because it's an alkane, so that means they are saturated, which means that they would all be making 4 bonds in total. तो ये सारे तो H हैं. They're all H atoms. So all of them are H atoms. The next thing is whether this molecule is planar or not. So how do you figure that out? It's let's focus on this carbon atom, this one over here. Is this planar or not? First thing, when carbon makes 4 bonds, it is tetrahedral, which means that one bond is, so when carbon is making 4 bonds, every one of the carbon atom is tetrahedral, and the angles are 109.5 degrees. So one hint that you get from here is, I mean, this shape can never be planar. The reason this shape can never be planar is that, imagine the only shape that you know that is completely planar, the 2-dimensional shape. Imagine if this was planar. Planar ka matlab hai the carbon atoms are lying flat on the sheet or on the board. Okay, board pe. So imagine them lying completely flat. So they would form a regular hexagon. Okay, ignore all the hydrogen atoms. We don't care about the hydrogen atoms. So if all the carbon atoms were lying completely flat on this board, just like it appears to you at the moment, so it's a regular hexagon, and a regular hexagon has an angle of 120 degrees. So it has an angle of 120 degrees. If you know that a regular triangle has an angle of, I mean, if it's an equilateral, I don't know if all the angles are the same, it's 60 degrees. All of them are 60 degrees. So if it's a hexagon, a regular one, all the angles are going to be 120 degrees. But since every carbon atom is tetrahedral, it's impossible to keep all the carbon atoms at 120 degrees. The angle has to be 109.5. And the only way it could be 109.5 is if this has a 3-dimensional shape. I mean, I'll show you the shape of a of a cyclohexane. Okay, so I'll show you the shape of a cyclohexane, and I think this gives you a very good idea. Okay, even this one. Okay, both of them are Kangi shape. Just a second, let me. And this one. So this one, this shape over here, you can see each of the carbon atoms, the black ones are carbon atoms. Remember that it's not lying flat, it's a 3-dimensional. The carbon atoms are forming a hexagon, but the hexagon is a 3-dimensional hexagon. One of the carbon atom is upwards, one of them is downwards. So it's a 3-dimensional hexagon, not a 2-dimensional hexagon. Jisse yahan pe, it would have been planar if all the carbon atoms were like this, they were completely flat. But the thing is, every carbon atom is tetrahedral. So the carbon atoms, all of them, some of them would be upwards, some of them would be downwards. So it's going to be a 3-dimensional. It's going to be eventually a 3-dimensional shape. This one also kind of shows the exact same thing, that the carbons, you can't just keep the carbon atom in a straight line because the angles are 109.5. So all of them are 109.5. So some of the carbon atoms are upwards, some of them are downwards. So, I mean, they're not flat, they're not planar, okay? So is this clear? Okay, when you have this, the carbons are tetrahedral and it cannot be planar. You just can't keep them in the same plane. Is this clear? Yes or no? Is this clear, Siddha? Is this clear?
Yes.
So remember this thing. I mean, make sure you remember this point. This one was a difficult question. Most of the other questions are going to be very straightforward. Because in this one, you had to be very, very specific. Most of the other questions would be kind of very straightforward. We can look at the other questions very quickly. Let's do some theory questions as well. And where's the shape of molecules? So these ones, most of the other questions would be very straightforward. For example, this one, AlCl3, they're just asking for the shape and the angles. So what are the shapes and what are the angles over here? AlCl3, it just makes 3 bonds. So that is fan shape, trigonal planar. And the angles would be 120 degrees. So you just have to remember that. Trigonal planar, that is fan shaped. And all the angles are going to be 120 degrees. What's the shape of PCl3? Now, PCl3 is, if you draw PCl3, like if you just randomly draw PCl3, P has a lone pair because it's in, remember, you have to count the lone pairs. P is in group 5, which means it's got 5 electrons, which means that 3 of them are bonding. So it's got these 2 electrons left, which are lone pairs. So if you've got 1 lone pair and 3 bonds, what shape do you have? You just have to remember the shape, which is already drawn above. So if you've got 1 lone pair and 3 bonds, it's like a pyramid. It's trigonal pyramidal, derived from a tetrahedral shape. The lone pair is sitting on top, and the 3 bonds are below it. So this one would be, if you sketch the shape, it's going to look like this. Draw a 3-sided pyramid. So it's like a fan with the fan blades pointing downwards, because the lone pair above is pushing them down. So this is trigonal pyramidal, and the angles are going to be 107 degrees. We can do a few more. He's asking for the So3 shape, and he's already told us that all of the bonds are double bonds. So that means So3 is this thing, trigonal planar. Does it have any lone pairs? Sulfur is in group 6, which means it's got 6 valence electrons. So over here, in this case, 2 got shared over here, 2 got shared over here, 2 got shared over here. There are no electrons left. So sulfur has no lone pairs. It's just 3 pairs of bonds, and it's going to be fan-shaped, trigonal planar, and the angles would be 120 degrees. What about Cl2O? So it's O with 2 Cls. So it's O with 2 Cls. Now, this is not the shape. I'm trying to figure out how many lone pairs it's got. So oxygen is in group 6, which means 2 of the electrons are bonding, 1 over here, 1 over here. So out of the 6, 2 are bonding. So that means 4 electrons are left. So an oxygen has 2 lone pairs and 2 bond pairs. So what would be the shape like? So when you have 2 lone pairs and 2 bond pairs, the shape is derived from a tetrahedral shape, but it's a bent shape because the lone pairs don't count. There's nothing attached on that side. So this molecule over here would actually look like this. I mean, it's got 4 things around it. So it should have been tetrahedral, except for the fact that on 2 sides, you've got a Cl bond, and on 2 sides, they're just lone pairs. So there's nothing there. So the shape is just bent, and the angles are 104.5 degrees. So pretty straightforward questions. Same thing over here. He's asking for the H2s shape, which is kind of the same thing because it's S with H, 2 H's. So out of the 6 electrons that S has, two are bonding, so there are 4 electrons left. So again, I mean, the shape is derived from a tetrahedral shape. So there are, on 2 sides, you've got a hydrogen atom, and 2 sides, you've got a lone pair. So there's nothing there. So it's just V-shaped or bent, and the angles are 104.5. So pretty straightforward questions, most of these, especially the shape ones. SF6, what happens if you have 6 bonds? When you have 6 bonds, it's an octahedral shape, okay? So is this all clear about shapes of molecules? Clear, Sara? Achha, ab ye ke, what we're going to do now is we're going to continue with the we were discussing this thing that you were discussing. Okay, permanent dipoles get cancelled out depending on the shape of. So just a quick recap. We were talking about molecules, and we were talking about permanent dipoles. That was a type of intermolecular force, and there were 3 types of intermolecular forces. You had permanent dipoles, so you had a bunch of molecules. They would attract each other with some very weak force of attraction, and that weak force of attraction is, it's either a permanent dipole or a or what do you call a hydrogen bond or van der Waals forces. So you have these 3 main types of forces, and we had started looking into permanent dipoles. And permanent dipoles, where you had the most electronegative elements in this corner. So if you have an HCl molecule, what will happen with an HCl molecule is that the electrons would be unevenly distributed. So that would result in a permanent dipole, which is an unequal distribution of electrons in a bond, which results in a positive and a negative charge on the atoms. A slight positive and a slight negative. The electrons are closer to Cl. So you got polar molecules, and the polar molecules, they attract each other. The negative part of one Cl would attract the positive part of the hydrogen of the other HCl molecule. And there would be this weak, remember, it's a weak force of attraction. All intermolecular forces are relatively very, very weak. So when are they found? When there's a difference in electronegativity. And the second point was that the permanent dipoles don't get cancelled out depending on the shape of the molecule. So we're going to talk about the dipoles getting cancelled out first. So let's continue with intermolecular forces. Sorry. Just 1 second, lost the board. As a permanent dipoles. So first thing, there must be a difference. There must be a difference in electronegativity. And the second one is that the dipoles don't get cancelled out. And that depends on the shape of the molecule. So we just went through all the shapes. So what does that mean? It means that you've got a molecule like a CO2 molecule. You got a CO2 molecule and you got an SO2 molecule. Both of them are kind of similar. Both of them have an atom in the middle and it's forming double bonds on both sides with oxygen. So that's a CO2 molecule and that's an S2 molecule. Kind of the same thing, it's SO2. So you got an SO2 molecule. Now the thing is, इसको थोड़ा सा ऊपर कर ले. Now the thing is, shape is important. So we first figure out the shape. So this particular molecule has exactly the same shape because carbon has no lone pairs. Carbon is in group 4. So 2 electrons getting shared over here, 2 electrons getting shared over here. So that's it. It doesn't have any other thing. So the double bonds would be as far away from each other as possible, and it's going to be linear, and the angle would be 180 degrees. That is what the angle would be. But over here, in the case of sulfur, you've got a lone pair because it's in group 6. So that means 2 electrons shared over here. So there are 2 electrons that are left. Now, if you have 2 bond pairs and 1 lone pair, the shape is like this. I mean, it's going to look like this. It's got 3 things around it. So the shape would kind of look like a fan shape. So it's going to be having 3 things around it. And on the other side, there's going to be, I mean, there was this side as well, but this side will have lone pairs. So this side over here will have lone pairs. So it's like a fan with one part missing. So that top is missing. So the shape is going to be like this. And the angle would shrink from 120 to around 119, or we can say it's approximately 120 degrees. So anyways, the shape of the molecule is slightly different. SO2 looks like this. CO2 looks like this. I'm gonna even rub this shape off. And I'm gonna just keep this shape. So one of the shape is a bent. It's a bent shape with lone pairs on top. Okay, so one of them is a bent shape. And forget the angles as well. Okay, so we figured out the shape. This is how the molecules look. Now, between all these atoms, oxygen is the one that's more electronegative. So oxygen is very electronegative. Oxygen is, if you look at the periodic table, it's right in the corner, top right corner. So it's very electronegative. So what happens is oxygen really strongly attracts electrons. So oxygen is going to try and pull the electrons towards itself. This other oxygen will also try to pull the electrons towards itself. So imagine what's going on. There's an oxygen over here that's trying to pull electrons to one side. It's like a tug of war that's going on. There's another oxygen on the other side that's trying to pull the electron on the other side. And they're both oxygens, which means they're pulling the electrons with equal force. One of them is pulling electrons in this direction. The other one is trying to pull electrons in the exact opposite direction. So they're pulling electrons with equal force, which basically means that the electrons are going to stay wherever they are. They're not going to get pulled in either direction. I mean, the forces of attraction are going to get cancelled out. You can think of 2 people fighting over something. One of them is pulling it on the right side. The other one is trying to pull the electrons on the left side. So the thing would remain right in the center. It's not going to go anywhere. And the dipoles are going to get cancelled out. So this molecule is not going to be polar. The electrons would remain evenly distributed and right in the middle. They're not going to go to either side. They're not going to shift to the right or they're not going to shift to the left. They would stay wherever they are. So is that clear? ये clear है सारों को?
Yeah.
ठीक है, बाकियों को is this clear? Yes or no? Mahat, clear hai? Hania, Aisha, is this clear?
Yes, sir.
Achha, but so remember the shape matters. Okay? So this is going to be a non-polar. It's going to be a non-polar molecule. Achha, this other one. Let's look at sulfur dioxide. Okay. यहाँ पे क्या हो रहा है? Same thing. Oxygen is very electronegative, so oxygen is going to try and pull the electrons towards itself. This other oxygen is going to try and do exactly the same. It's going to try and pull electrons towards itself. So over here, the forces of attraction are not going to get cancelled out. I mean, think of, there's a thing that's over here. I mean, think of something over here. There's one person trying to pull it in this direction and another person trying to pull it in this direction. Their forces will not cancel out. The thing will get dragged downwards, which means the bottom side of the molecule would become slightly negative and the top side would become slightly positive, because both oxygens are basically trying to pull the electrons downwards. Afi, are you talking about this particular statement? I mean, that's what I'm trying to explain, that whether a molecule has a dipole or doesn't have a dipole, it depends on the shape of the molecule. So if you have a CO2 molecule, the dipoles will cancel out because the shape of the CO2 molecule is linear. It's one oxygen on this side, one oxygen on the other side. So the oxygen is trying to pull electrons towards the right. This oxygen is trying to pull the electrons towards the left. So the force of attraction would get cancelled out. The electrons would just stay in the middle. They're not going to go to either direction. So there's not going to be any slight negative or slight positive side, and it's going to be a non-polar molecule. There's not going to be any polarity on this molecule. Then आपके पास, you've got SO2. SO2 has a bent shape because there's a lone pair that's sitting on top. So the bonds get bent downwards. They get repelled downwards. In this case, the oxygens are trying to pull electrons, and this time both oxygens are trying to pull electrons downwards. So the net result is this entire molecule, the bottom side becomes negatively charged and the top side becomes slightly positively charged. Okay? Is this point clear? You clear? Yes or no?
Yes, sir.
So we'll do this with other shapes as well. Okay? So remember this, dipoles getting cancelled out, or dipoles, I mean, so difference in electronegativity is not the only thing. It depends on the shape of the molecule as well. So here's another one. Can anyone quickly tell me whether this is going to have a dipole? Cl is very electronegative, so the shape is fan shaped. I mean, the Cls are trying to pull electrons. I mean, this one's trying to pull electrons. This one is trying to pull electrons. The one at the top is trying to pull electrons. What's going to happen? Is it polar or non-polar? Will the electrons go to one side or will they just remain evenly distributed everywhere? क्या होगा, polar or non-polar?
Non-polar.
Okay, this one is going to be non-polar. Okay, think of electrons over here, one trying to pull it upwards, one over here. So I mean, the electrons would stay, I mean, right in the middle. They're not going to go anywhere. So the dipoles over here, although there is a difference in electronegativity, they are going to get cancelled out. So what about so let's think of a similar molecule, but this time we have you've got an oxygen and there are two H atoms attached to it. So it's again trigonal planar, but this time there's one atom that is very electronegative. So, and that's oxygen. Oxygen is one of the most electronegative elements. So there's one atom that is strongly pulling electrons to one side. So I mean, there's a disbalance. It's one of the sides is strongly pulling the electrons. So the electrons are going to go to that side, and the other sides would become slightly positive because the electrons are going to get pulled towards oxygen. What about What about SF6? Let's talk about SF6. Now, fluorine is one of, it's the most electronegative elements out there. But will the molecule be polar or not? So you got fluorines everywhere, on top, on the left side, bottom side. There's one that is behind it, and there's one fluorine that's right in front of it. So polar or non-polar, this one. अच्छा एक उसके पीछे भी है. So is this going to be polar or non-polar? So it's going to be non-polar because even though fluorine is one of the most electronegative elements out there, लेकिन all the forces of attraction are getting cancelled out. ये यहाँ पे खींच रहा है, वो उधर खींच रहा है. So the electrons would just stay wherever they are. One of them is trying to pull them upwards. One of them is trying to pull them downwards. The electrons would just stay wherever they are. एक सामने की तरफ खींच रहा है, one of them is behind it, but all the dipoles will get cancelled out. So this one is non-polar. ये भी cancel out हो गया because this one is non-polar. So you have to be careful about shape and the difference in electronegativity. और दूसरा ठीक है, so you do get questions where you have similar types of elements. ठीक है, what if you have ये कर लेते हैं कि what if you have this one, C double bond O, and on one side you have an F atom, and on the other side you have another F atom. Now the thing over here is that the dipoles would almost cancel out because all three of them are very electronegative. So this particular molecule, the dipoles will cancel out, or we can say that the dipoles almost get cancelled out because the electronegativities are very similar. So remember this, when we say a molecule is non-polar, it's not, so this would be very close to being non-polar. It's not that it's going to be 100%. Exactly. So the thing is, it's not, so that's why I'm using the word almost. That oxygen is electronegative, fluorine is just slightly more electronegative. So the difference in electronegativity is not that much. You need a difference in electronegativity. Oxygen and fluorine, the electronegativities are kind of similar. So we can check the Pauling scale to be very specific. So यहाँ पे there are values that are given. If we can see this one. This one shows values. So you can see that as remember you wouldn't be given any table like this. You just have to know that the corner is electronegative. So you can have a look over here. You can see that fluorine is obviously more electronegative, but oxygen and fluorine almost have very similar electronegativities. So the thing that I'm trying to state over here is, that's why I use the word almost, that it's almost non-polar. So we can say it's almost non-polar, or we can say it's very, very weakly polar. You clear? So you have to account for that. So we can say that when we talk about difference in electronegativity, we can add to it that if there is more difference, a bigger dipole is produced. So if there is more difference, to a larger dipole is produced. Lesser difference, a weak dipole is produced. Or we can say that the molecule is almost non-polar. So for example, if I have three molecules, बस ये इधर खत्म कर लेते हैं dipoles वाला, कि if I have three molecules and I've got HF, I've got HCl, I've got HBr, and I've got HI. So out of the three, which one is the most polar? कौन सा वाला? First one or the last one? नहीं, लोन पे तो कहीं नहीं है बीच में. We're not talking about loan pays. I mean, so the last one is the least. ठीक है, HBr is going to be more polar. HCl is going to be an even more polar molecule because the difference in electronegativity is increasing, and this one would be the most polar. ठीक है, so the trend would be that the difference in electronegativity is increasing. अच्छा, उसको डिस्कस कर लेते हैं. There was a comment. एक सेकेंड, ये निकले, difference in electronegativity increases. अच्छा, ये तो हमने लिख लिया. अच्छा, the thing about loan pairs, remember के क्या था comment के if you have the most electronegative element in a molecule or a lone pair, then a molecule is non-polar. नहीं, the molecule is non-polar in two cases. One is that either there is no difference. I mean, a lone pair has nothing to do with the polarity. Lone pairs determine the shape of a molecule. Okay? So it has nothing to do with the polarity. It just determines the shape of a molecule. Okay? How would the molecule look? A molecule will be non-polar. Either there is no difference in electronegativity or the dipoles are getting cancelled out. कि वो shape इस तरीके की है कि the shape, I mean the dipoles, they get cancelled out. ठीक है, इन दो केसेस में ना मॉलिक्यूल नॉन पोलर होगा. तो ठीक है, लेट्स कंटिन्यू टुमारो. कोई और क्वेश्चन तो नहीं है अभी? इज दिस क्लियर? ठीक है, चलो लेट्स कंटिन्यू इन द नेक्स्ट क्लास देन. ठीक है, टेक केयर एवरीवन. अल्लाह हाफिज.
Allah Hafiz.